I need to do it. है ना? So that way you need to keep your VLSI notebook. You can combine practical and theory sessions over there, not an issue, because in practical also you need to write something. And we'll be signing that you have completed this, and that way you'll be getting your marks for your practical assessment as well as the IA. Are you getting? So I want lecture 1, date and note. 1 page, 2 page, whatever you want to. So only sake of I am saying that you need to take out the notes. That's why you will be writing in 1 point, 1 point. That should not happen. It should be understood by you only. In that way, that mindset, just write the things. Is it clear, everyone?
Yes, ma'am.
Yes, ma'am.
Hmm?
Yes,
So
ma'am.
that
Yes,
habit you
ma'am.
need to make. Okay. So that is there. If any issue, I am not able to communicate you properly, you are not able to understand the thing at any type of the lecture, you can interrupt me. Okay. So that way, whatever I am saying now, PDA, many of the students have not written. है ना? But I feel most of the student will be Gajni. They will not be remembering that whatever topic you learned for the long time. है ना? That's why something should be there in somewhere. Instead of writing एक और पेज ले लिया, second lecture के लिए और पेज ले लिया, and you are then putting the pages here and there. Instead of that, make a diary, make a make a book, notebook, and just write it over there. So everything will be with you at proper time. Okay. So that things. So I'm again moving towards this PPT. So these are what is the VLSI technology. I told you VLSI goals. क्या है target of VLSI? 3 points I told you. Be interactive beta.
PDA.
PDA. P means power, D means delay, and
Power,
A means area.
delay.
Yeah, area. So what is meant by power? Can anybody elaborate? अगर मैं मोबाइल लेती हूँ and I am charging every time charging the mobile, है ना? In 24 hour I need to charge that mobile thrice or four time. Is it proper? Is it
No.
proper? No, I want standby time. Like when I am charging it once, it should be charged over there for at least day or 2 day over there. So my power requirement of that particular device should be less. है ना? So that is my first requirement. Now you are able to see fast chargers are there. Only in 5 minutes you are able to charge your whole mobile for a that you can use for a day. है ना? So that particular enhancement. Previously you need to charge it for 1 hour. है ना? But now the things are advanced over there. So this is P. Second, now if I'm saying power, so whatever the components you are using in that particular laptop or something in mobile, so that should be consuming less power. So if I'm saying transistor, which is a basic part of your VLSI technology, so it should consume less power. है ना? Power dissipation in that particular component should be less. So that is our requirement. अगर वो component बड़ा है, so it will be consume more power. If that component is small, so it will be consume less power. That way, technology is enhancing every time. Now, second part is delay. Now, if I am clicking a picture and I am able to see that picture after 1 minute, is it proper? No. The execution speed or processing speed should be fast. You are able to see the so many laptops now. The processing is the speed is very fast. Means frequency of operation is very fast over there. So this is what is a technology enhancement. Every time your device become fast for the upgradation to the new technology. So this is the requirement. I want everything to be faster. है ना? Nobody wants the laptop which will be operating slowly. है ना? So that way, second point is the what? Delay. Delay should be less. And area. I'll not be preferring a phone to carry which will be occupying space like a laptop. Isn't it? It should be compact. It should be handy. I should be able to move that particular phone anywhere easily. It should fit into my pocket. So that way, area wise, it should be compact. Is it clear that 3 points? What is the goal of VLSI? Yes.
Yes, ma'am.
Yes, ma'am.
Hope I am audible. Huh? So that is the thing. So PDA, that is the main thing. Now I have modified the this PPT for something. Okay. Huh. So now introduction to VLSI. Now VLSI, as I told you, this HDL comes under VLSI, stream or field of VLSI. So what is this VLSI? So it is a process of creating integrated circuit by combining thousands of transistors into a single chip. Previously, you know that things are getting manufactured by putting different discrete component, that you will be having diode, you will be having some what gates, you will be having transistor, capacitor, inductor, you will be placing it on the board, and then you will be connecting. So discrete component are combined together to form certain logic. Okay, but what is the drawback of that discrete component connecting each other on the board? Then comes the integrated circuit, that is IC, where thousands of components are there on a single chip or single wafer, and that wafer you are able to see this left hand side. You are able to see small wafer is there. Inside that you are having thousands of transistor or different component, and the logic is created. It will be functioning as per your application. Are you getting? Are you getting, guys?
Yes, ma'am.
Yeah.
Ma'am.
So
Yes,
just
ma'am.
tell me what is the disadvantage of previous things what we were doing, that is discrete component um, connecting on a chip. उसका disadvantage क्या होगा? PDA type from the point of PDA also you can think, है ना? बताओ.
It will take more area.
Complexity.
Yes, definitely it will be taking more area, क्योंकि मैं एक device यहाँ पे डायोड लगाती हूँ, यहाँ पे कैपेसिटर, so I need to keep some distance for connection over there, isn't it? So it will be occupying the area. Second, power. Definitely I am having that device which will occupying more space. It will be somewhat more large over there, and that's why it will be occupying, means it will be requiring more power. Power consumption will be more. Okay. Yes.
Yes, ma'am.
And delay, as it will be having more area, it will be over more area, delay will be more. But now if everything is on this small chip, definitely delay will be less, power consumption will be less, area will be less, and that's why next thing is that if you are going to solder this different discrete component, definitely there will be dry soldering, there will be debugging issue, you need to debug everything, isn't it? And if dry soldering is there, means you will not be getting proper output. And that's why, to avoid these issues, there comes a VLSI in which uh, thousands of components will be there on the single chip. Thousand or more than that also. Now technology is enhancing, so your that particular transistor is becoming smaller and smaller. Nanotechnology mean nanometer technology is coming over there, and that's why that shrinking of transistor is there, and that's why if the transistor is shrinking, definitely area wise, definitely power wise, it will be consuming less power, less area. Are you getting? Hope the point is clear to you. यस बोलने के लिए इतना देर मत रखो, नो बोलना है तो भी बोल सकते हो. आई विल बी अगेन एक्सप्लेनिंग दैट थिंग, बट प्लीज रिप्लाई
Yes,
फास्ट.
ma'am.
Okay. So now over here, VLSI was begun in 1970s when complex semiconductor and communication technologies were begin developed. Now, a microprocessor is a VLSI device. One student just told me that it's a microprocessor. Yes, microprocessor is a VLSI design. So उसमें क्या रहता है? There is a IC, there are different ADCs and something different components are there on a single board over there. So this is what is a VLSI, very large scale integration. Now, microprocessors are essential to many products such as laptops, TV, tablet, and whatnot, washing machine, cars, communication, high-speed communication networks over there. So this is a what VLSI. So definitely VLSI is everywhere. Now transistor is the main component of microprocessor. Now what is mean by this? Transistors are the main component of microprocessor. So here transistor means what? Can anybody comment?
BJT.
Hold 1 minute. Sir, I am in lecture. मी नंतर phone करू का? Okay. Now everyone knows that transistor is a BJT. Okay, bipolar junction transistor. But here in VLSI, just keep that thing in mind. Whenever I'm pronouncing transistor, it is a CMOS. What is mean by
Yes.
CMOS? Can anybody comment? CMOS means MOSFET पढ़ा है आपने? PMOS, NMOS,
MOSFET.
P channel. हाँ, तो वो क्या है? उसका लॉन्ग फॉर्म क्या है? CMOS. What stand for?
Complementary metal oxide
Metal
semiconductor.
oxide
Hmm?
semiconductor.
हाँ, semiconductor. FET.
Complementary metal oxide semiconductor.
उसके बाद में FET है ना बेटा? Field
हाँ,
effect transistor.
Field effect
transistor.
है ना?
transistor.
हाँ,
Yes.
तो you have recalled something from the second year, I think so, first year. Okay, so that is CMOS. Now, why CMOS is preferred? Because you know BJT. BJT क्या है? It's a current control device. You are giving some base current, collector current होता है, फिर emitter current होता है, and that's why it is a current control device. But this MOSFET is the voltage control device. Small gate voltage controls the drain current. Are you getting? Are you able to recall the concept? That in that you are
Yes.
giving IB, base current, but here you are giving some VG. Okay, this is not a part of this particular subject over there कि कैसे work होता है, but at least you should be able to recall that there is source gate drain terminal and one is the substrate or body. Whenever you are applying gate voltage over there, that whatever the physical channel will be formed, and once the channel is formed, that electrons will move from one direction to another direction, and that's why there is a flow of current, and that's why your device will turn on. Are you getting? So small voltage controls large current, that is the drain current. Now over here, over BJT, you are having some advantages over here for the CMOS, that it consumes less power, and that is the requirement. है ना? PDA stands for power delay area. So power consumption should be less, and transistor consumes large, more power over there.
रियाज ने पता क्या कहा रोहित शेट्टी होगा अपने घर का देखो वीडियो तुम अब क्या कह रहे हैं कुछ नहीं ट्राई किया सर कुछ मैं तो अटक
Hello.
के दिखा दिया आ गया बंदा लड़ने के लिए
Who is there? This should not happen in the lecture. Purposefully also and without purpose also. Something is important, you need to totally concentrate on this. Hope this will not be happening again. Okay. So over here, that transistor means a CMOS because it is having advantage over the transistor. It consumes less power. Voltage swing is more, that there will not be any losses. If I'm giving 5 volt, I'll be getting 5 volt. If I'm giving 0, I'll be getting 0 volt. Many times there will be voltage drop, and that's why instead of 5, who is this person? If you don't want to join or attend the lecture, you can leave the lecture session. All of you getting this thing. Because of this one person, every means whole this session is getting interrupted. If this happen once again, I'll be closing this lecture and I'll not be conducting any session hereafter. I'll be getting your name anyhow from the students or anyone. Otherwise, I'll not be continuing the sessions. No requirement from my side to conduct a lecture. This should not happen. This is the final call. Final warning I am giving. So here transistor we are considering is the CMOS. Is it clear up till this point? Is it
Yes,
clear?
ma'am.
Okay. So CMOS transistor is not a BJT in VLSI, it's a CMOS. Okay. Now above CMOS also quantum physics is coming. That way the things are happening because we require fast operation, compact circuit, and fast less delay. So that's why the things are there. Now, goal of VLSI is to improve PDA that I already told you, power delay area. Now, this is very, very important to understand what is front end and what is back end. Whenever you are going ahead with the VLSI terminology or field, okay, two things are coming, that is front end and back end. You want to pursue your job or your profession in which field? In the VLSI, that is front end and or in back end. Now, what is meant by front end? Front end means that you are having design and testing part of Verilog or other HDLs. So HDL stands for hardware description language, the language which describes the hardware. Okay. Now, many of the time it happens like that. You know the functionality, how to write the program, but you know don't know how that circuit is. है ना? So there is no requirement over here in this HDL to know the circuit. If you know the functionality, you'll be able to get your hardware or gate level design of your application. Are you getting? Is this point clear? What is meant by HDL? Hardware description language, the language which describes the hardware. There is no need to understand the circuit of your application or your functionality. Suppose I want to design a counter, how that counter will be there in the block diagram or connection. I don't require that. If I know the functionality, I'll be writing that in the coding, and this HDL, that Verilog tool, whatever we are using, that will be telling you how the circuit will be. So there is no requirement of understanding gate level design of your application. Hope the things are clear. Hope the things are clear. This is very important.
Yes, ma'am.
Yeah.
Yes.
So whenever you're writing something, you're writing RTL. RTL means register transfer language or level. ऐसे बोल सकते हैं, language बोल सकते हैं. So RTL you need to write that you need to write a code for particular application. Suppose I'm saying counter, I'll be writing a code for counter. Then for checking the correctness, because I have written a counter, but whether it is working properly or not, functionality wise, it will be functioning like up counter, down counter, loading is happening properly or not. For that, I need to test. जो भी है test करना is very important, isn't it? So if you are testing the hardware is with you, then it is called as a testing. But whenever you are having the design in soft, you are having, it is called as a verification. Is it clear? What is the difference between verification and testing? Verification is the correctness of your design, and testing means correctness of your device. Hardware is available. You are testing IC, है ना? But if you are having design with you, you are testing it or correctness of that design is called as a verification. Is it clear? Hope you are writing these points in your book.
Ma'am, can you repeat verification testing once again?
Yeah. So verification and testing, these are the two things. Verification is the correctness of your design and a code you have written, and that you need to check it whether it is functioning properly or not. So it is not yet in the hardware form. It is just a program. It is only a design. Are you getting? So correctness of your design is called verification. Okay. And
Yes, ma'am.
to check the correctness of your device means you are having in hardware is there, IC is there, and you are testing that. आप बोलते हो क्या मैं IC वेरीफाई करने जा रहा हूँ? नहीं, you are testing that IC. जो आपका एक रहता है ना टेस्टर, IC टेस्टर, उसमें आप IC डालते हो और then you are giving VCC ground something means that automatically it is going to test. So that is what is the testing, because you are testing or you are checking the correctness of your design device. Okay.
Yes,
So
ma'am. Got it.
verification is the correctness of your design, and testing is the correctness of your, yes,
Device. Device.
device. Yes, perfect. ठीक है. तो जो आप लिखोगे, कोड लिखोगे, आरटीएल लिखोगे, और टेस्टिंग करने के लिए कुछ लिखना पड़ेगा मुझे, बिकॉज सपोज आई एम हैविंग द एंड गेट और उसका डिजाइन मेरे पास है. डिजाइन मीन्स आई एम नॉट हैविंग अ हार्डवेयर, मैंने कुछ तो भी कोड लिखा है, एंड फ्रॉम दैट आई एम जस्ट इम्प्लीमेंटिंग द एंड गेट. सो मुझे टेस्ट करना पड़ेगा. नाउ फॉर टेस्टिंग पर्पज व्हाट यू नीड टू डू एक्चुअली, you are giving 0 1 IC जब रहती है आपके पास, so you are giving A to A pin, B pin you are giving 0 0 0 1 1 0 0 0 0. So that way you are giving the hard input, isn't it? VCC or ground. But now in design, are you able to give hard input? Yes. In design, are you able to give VCC ground? Make it fast, beta.
No.
No. So मुझे क्या देना पड़ेगा? I need to give soft input over there. Stimulus, vector, है ना? ये सब नाम एक ही इसके है. Stimulus में soft input. Okay? I need to generate that. मुझे A को देना है, B को देना है, तो I need to generate 0, 0, 0, 1, 1, 0, 1, 1. तो वो जो generate करता है, उसको बोलते हैं test bench. This is again a very, very, very important point. At the time of practicals, you'll be getting, but you should be know. You feel that very hi-fi test bench लिखना है मुझे. You feel that it's very difficult, but it's very simple. So what is test bench? For generating stimulus, you need to write that test bench. For generating soft input, किसके लिए? For design under test. इस एंड गेट आपने लिखा है तो उसको इनपुट देना पड़ेगा. वो इनपुट कहाँ से जनरेट होंगे? That test bench will be generating that and it will be given to your design, and then it will be getting tested whether it will be giving output properly as per your truth table or not. Hope the things are clear. This is very important point. समझ में आया सबको?
Yes,
समझ
ma'am.
में आया? हाँ. So over here, that is very important. Again, in this coming slide, I am having that particular things properly explained. So this is what means. Whatever you are able to write, you are not able to physically see something, or physically something is happening that you are not able to see. So that is the front end. Is it clear? Now what is back end? Development and fabrication. This is the physical thing, isn't it? Are you getting main difference between front end and back end?
Yes.
Hmm? तो ये development में you need not have to write a code. Proper fabrication is there, है ना? Placement, routing, that you need to do. Floor plan you need to do. Now I have uttered this so many words. Now what is the meaning of that? Whenever you are designing IC, ये जो है ना final, this is what is the VLSI design flow. This is very important first point of your session. Okay, I'll be sharing one video of Dr. Rashmi Mahajan madam as well as mine. So in that I have explained that thing properly. I'll be sharing link or Google Drive. So just go through that. Okay, after this session you need to go through that. In the next session I'll be asking questions on that. Okay, so that particular notes also you need to write in your notebook. So here specification, system specification. ये क्या है? Anyone able to tell me ये क्या है? What I told you? VLSI design flow. क्या है ये?
VLSI design flow.
So this is very important. And HDL design flow is different one. Programmable logic design flow, this is big different. Because here you are not manufacturing the IC. IC is already there. You are dumping bit file. जैसे microcontroller में करते हो. So don't get confused here. Hope the things are clear. Now in fast I'll be telling, I'll not be elaborating that way. You just go through that link and just clear the things. Over here system specification, that I want system to be fast, compact, power dissipation wise, how it will be, at what frequency it should be working, everything that specification you require for particular application, that I need to design a logic for washing machine or toy car or something like that. Keep that application in your mind, and depending upon specification you'll be putting your specification over here. Then you'll be designing the architecture, that how it should be. Architecture may I want this block to be here, this block to be here. That way I'll be having architecture over there. Okay, so I want architecture over there. Now once that architecture is there, you need to write a Verilog code or VHDL code. So functionality implementation purpose, you need to write a Verilog code. So in that you will be having entity if you are going ahead with the HDL, VHDL, and if you are going ahead with the Verilog, you will be writing module. Now in HDL, that is hardware description language, there are two languages, HDLs. First is the VHDL, very high speed integrated circuit hardware description language, and second is the Verilog. In our syllabus, we are targeting Verilog because in industry, most of the cases and for the verification purpose, Verilog is preferred. Hope the things are clear. Yes.
Yes.
Yes, ma'am.
So here functionality
Yes,
and
ma'am.
whatever logic you want to implement, that I want to implement logic of counter, I want to implement logic of AND gate. So that thing you will be implementing over here in this particular box. Then I told you, you don't have to understand the how circuit is going to be seen, because there is a synthesis. This is also very important. What is meant by synthesis and what is meant by simulation? So now just tell me, if I'm talking in French, are you able to understand French?
No, ma'am.
No.
No, ma'am.
So I need to talk in English so that it will be understood by you. So if French person is there, he is talking in French. So if I want to understand that I will be having translator, isn't it? Which will be translating that French into English, isn't it? So over here, same thing is happening, that if I am writing a code in very long, so what is written, that particular tool should be knowing. So what it will be happening, the synthesis is a process which will be converting that high level code into gate level netlist. What is meant by synthesis? Synthesis is a tool which will be converting your high level Verilog code into gate level netlist. So it will be whatever you are writing, syntax you are writing, it will be converting that particular code syntax into its some gate level diagram. This we will be seeing in the lab. Is it clear? What is synthesis?
Yes, ma'am.
हम्म? तो आपने जो कोड लिखा है यहाँ पे वो क्या रहेगा? Because if I am writing something in if else, it will be generating its mux or encoder. If I am writing something over here case statement, it will be implemented as a priority encoder. So that way, for each and every syntax there is a some hardware dedicated. एंड दैट वे इट विल बी कन्वर्टिंग. ट्रांसलेशन मीन्स क्या होता है, मैं फ्रेंच में कुछ बोलती हूँ तो इंग्लिश में उसका कन्वर्जन के लिए कुछ तो भी होगा. सो दैट वे ओवर हियर, इफ आई एम राइटिंग कोड, इफ एल्स स्टेटमेंट, केस स्टेटमेंट, whatever the loop statement, exist statement, so that is having its own hardware. So that is called as a synthesizable statement and non synthesizable. सिंथेसाइजेबल मीन्स जिसका कुछ हार्डवेयर जनरेट होता है ना. एंड नॉन सिंथेसाइजेबल मीन्स which is not having any hardware. Delay. What is the meaning of delay? Is there any hardware required? It has to just wait, so there will not be hardware. So this is non synthesizable. Are you getting? टेंजेंट नहीं जा रहा है, ऊपर से नहीं जा रहा है. सो सिंथेसाइजेबल, नॉन सिंथेसाइजेबल. सिंथेसाइजेबल मीन्स जिसका कुछ हार्डवेयर रहता है, स्टेटमेंट उसका कुछ हार्डवेयर रहता है. और जो नॉन सिंथेसाइजेबल है, लाइक अ डिले, देयर विल नॉट बी एनी हार्डवेयर, है ना. जस्ट यू नीड टू वेट. सो दैट वे इट विल बी कन्वर्टिंग द हाई लेवल कोड इनटू गेट लेवल नेटलिस्ट. ओके, नाउ ये है आपका फ्रंट एंड पार्ट, जहां पे आप क्या लिखते हो, यू आर राइटिंग your RTL. For testing, you are writing your test bench. After comes from the physical design to chip, there is a back end. Now, what I told you in back end, front end means जहाँ पे आप actual coding करते हो. That is not physically you are able to see. But in back end, that is physical things are there. That you are able to see that you are having this IC. है ना? You need to fabricate that IC. तो यहाँ पे क्या है आपका? Wafer है. So in this wafer, consider this wafer as your what plot, जहाँ पे आप आपका घर बांधना चाहते हो. Are you able to relate? Are you with me?
Yes, ma'am.
Yes,
Yes,
sir.
ma'am.
5 मिनट रह गए हैं. आई एम ट्राइंग टू कवर द थिंग्स. नेक्स्ट लेक्चर कौन सा है आपका, कि छुट्टी है?
लैब है मैम. सारा दिन.
लैब.
छुट्टी है ma'am, छुट्टी है.
ब्रेक है ना रे, खाना पड़ेगा ना आपको, मुझे भी, है ना. सो जस्ट आई विल बी टेकिंग 5 minutes. आई जस्ट वांट टू कंप्लीट दिस पीपीटी. ओके. सो यू आर हैविंग प्लॉट, 30x70 का प्लॉट है, वहां पे आपको घर बनाना है. तो व्हाट प्लानिंग यू आर डूइंग? डायरेक्टली यू आर डूइंग गोइंग फॉर द फाउंडेशन?
मैम.
No,
नो.
ma'am.
तो क्या करता है, क्या करना पड़ता है? यू विल बी प्लानिंग, ब्लूप्रिंट बनाते हो. आई वांट माय बेडरूम टू बी हियर, आई वांट माय लिविंग रूम टू बी हियर, किचन टू बी हियर, बनाते हो, है ना.
Yes.
हाँ.
Yes.
तो ये क्यों बनाते हो? बिकॉज आई वांट एवरीथिंग शुड बी परफेक्ट, देयर शुड नॉट बी एनी इश्यू आफ्टर बिल्डिंग, है ना. वो फिर से करना, दैट इज वेरी हेक्टिक जॉब. सो आई विल बी प्लानिंग कि इन दैट पर्टिकुलर प्लॉट आई विल बी having the floor plan कि that particular 2 bedrooms should be here, kitchen should be here, living room should be here, है ना. and then only by having that, is it okay? मुझे 2 बेडरूम
No.
चाहिए, ये चाहिए नहीं, मुझे प्लेसमेंट करना पड़ेगा कि किचन मेरा साउथ ईस्ट में होना चाहिए, है ना, मेरा पूजा रूम साउथ ईस्ट में होना चाहिए, सॉरी ईस्ट नॉर्थ ईस्ट में होना चाहिए, दैट वे यू आर प्लानिंग समथिंग, इजंट इट? तो प्लेसमेंट करते हो दैट दिस इज 12 by 12 का रूम, आई नीड टू प्लेस इट ओवर हियर। आर यू गेटिंग व्हाट आई वांट टू ट्राइंग टू टेल यू?
Yes, ma'am.
हाँ, ये होने
Yes.
के बाद आई वांट टू डू राउटिंग, कि मुझे किचन से यहाँ पे जाना है, यहाँ से वहां जाना है, तो राउटिंग पाथ प्रॉपर होने चाहिए, कि घूम के नहीं होना चाहिए, एक्सेसिबल होना चाहिए, इजंट इट? इजंट इट? हाँ,
True,
तो
ma'am.
ये 3 वर्ड समझ में आ गए, फ्लोर प्लान, ब्लूप्रिंट, प्लेसमेंट, कौन सा रूम कहाँ पे है, एंड देन राउटिंग, कौन से रूम से कहाँ जाने के लिए मुझे एक पाथ देना पड़ेगा, इजंट इट? इजंट इट? डू इट फास्ट
Yes.
बेटा।
Yes.
हाँ, तो ये सब होता है यहाँ पे फिजिकल डिजाइन में, गॉट इट? So you need not have to do that thing by your own. There are tools available. That is the EDA tool. क्या बोलते हैं उसको?
EDA
EDA.
tool.
EDA
EDA.
stands for,
EDA.
हाँ, उसका लॉन्ग फॉर्म
Environment
क्या है?
develop.
हाँ,
Environment development.
इलेक्ट्रॉनिक डिजाइन ऑटोमेशन टूल। क्या बोलते हैं? लिखो, इलेक्ट्रॉनिक डिजाइन ऑटोमेशन टूल।
Electronic development.
Electronic design automation tool.
यस, सो इट विल बी टेकिंग केयर कि क्या करना है, कहाँ पे करना है। अगर मेरा entrance सामने, if hall is there, so how to give that entrance over there, so everything that will be taking care, कि मेरा जो गेट है घर का मेन गेट, उससे दूर नहीं होना चाहिए entrance, नियर होना चाहिए। So here if I am saying that I want to implement AND gate or A B, just see on the screen, I am just rotating my cursor, ये A है, ये B है, ये C है, तो मेरा डिजाइन इसके नजदीक ही होना चाहिए कि मैं यहाँ पे रखूंगी उसका डिजाइन, which is preferable, यहाँ पे करूँ कि यहाँ पे करूँ? यहाँ पे, isn't it? क्योंकि अगर मैं implement यहाँ पे करती हूँ तो routing delay unnecessary will be more, and that's why that thing will be taken care by your EDA tool. You need not have to take care. Clear? Clear?
Yes, ma'am.
ये होने
Yes,
के
ma'am.
बाद वो वेरीफाई करेगा, फिजिकल वेरिफिकेशन, कि वहां पे कुछ डिजाइन रूल के अकॉर्डिंगली वो चेक करेगा कि वहां पे ब्रिजिंग इफेक्ट तो नहीं हो रहा है, वहां पे शॉर्टिंग तो नहीं हो रहा है, प्रॉपर स्पेस इज देयर और नॉट, आपके जो कर्व्स है वो प्रॉपर है या नहीं, स्ट्रेट लाइन नहीं होना चाहिए। दिस रूल्स आर देयर दैट यू नो वेरी वेल, जब आपने पीसीबी किया होगा, है ना, लेआउट, तो वहां पे आपको मालूम है कितना डिस्टेंस होना चाहिए। सो दैट वे एवरीथिंग यू नीड टू डू, and this everything is implemented, this design is implemented in terms of your transistors, है ना। तो ट्रांजिस्टर आपको फैब्रिकेशन करना पड़ेगा, दिस पर्टिकुलर लॉजिक यू नीड टू इम्प्लीमेंट यूजिंग ट्रांजिस्टर, some gates over there, some flip flops you need to have, so that you need to fabricate, और वो फैब्रिकेशन इन टर्म्स ऑफ सीमॉस करना पड़ेगा। तो सीमॉस चैनल की लेंथ कितनी होनी चाहिए? 0.5 नैनोमीटर, 0.18 नैनोमीटर, दैट वे यू नीड टू गिव द फाउंड्री टू द फैब्रिकेशन लैब कि मेरा ये ट्रांजिस्टर 0.18 नैनोमीटर टेक्नोलॉजी का है या कितने टेक्नोलॉजी का है, आई हैव इम्प्लीमेंटेड, so that particular file will be given to the foundry कि I have implemented all this thing using this type of transistor, and once that has been done, fabrication में as you know doping होता है, photolithography होती है, oxidation and what not, है ना, तो वो सब steps होते हैं, and ultimately you are forming the IC, तो पैकेजिंग होता है, उसका टेस्टिंग होता है, एंड अल्टीमेटली यू विल बी गेटिंग दिस, क्योंकि हैंडी बनाने के लिए यू नीड टू हैव अ केस ओवर देयर, उसके पिंस होते हैं, एंड फाइनली दैट चिप इज गेटिंग मैन्युफैक्चर्ड। इज इट क्लियर? इज इट क्लियर?
Yes, ma'am.
हाँ, तो
Yes.
ये चिप जो जिस फ्लो में आपकी चिप मैन्युफैक्चर्ड होती है वो है VLSI डिजाइन फ्लो, और जिस फ्लो में आपकी आईसी में बिट फाइल डंप होती है उसको बोलते हैं HDL फ्लो और प्रोग्रामेबल लॉजिक डिजाइन फ्लो। ये हम देखेंगे नेक्स्ट सेशन में, दैट इन लैब यू नीड टू डू ऑल दिस थिंग्स। इज इट क्लियर?
Ma'am.
Is it clear? So
Yes,
these are
ma'am.
the companies. This is what is the HDL syllabus. I'll be telling you afterward. This is the hardware, that is you will be programming in your lab using this hardware which we are having over there. So FPGA, PLD, these are the programmable logic device. So this is one of the programmable logic device and the name is FPGA. Okay, this is what is the Verilog you are having in syllabus. So what is Verilog? It's basic from data types, data values, what are the different modeling style, how to code combination or a sequential circuit, everything will be in these 3 units. And next you are having जो मैंने बताया था, you will be designing something, you will be writing a code for that, then you will be testing using test bench, so you will be checking simulation, and then ultimately dumping the code into hardware, है ना? ये क्या है? Can anybody comment? अभी तक मैंने बताया था, अगर ये बता सकते हो means something you learn.
Gate level design.
क्या? Pardon? Yes, right. बोलो.
Gate level design.
Yes, synthesis. You have written this code. नाम क्या है बेटा आपका?
Swapnil.
स्वप्निल. Good. स्वप्निल कौन? Might be different
Swapnil
Swapnil, na?
Dabde.
Many Swapnil. Okay, good, good one. So code आपने जो लिखा, सिंथेसाइज करते हैं तो क्या होता है? गेट लेवल नेटलिस्ट. सो आपको ये देने की जरूरत नहीं है. वो टूल आपको दिखाएगा that you have written this code. So for that, this is what is the design. Are you getting? So that way it is very different from your microcontrollers. You are not able to see that thing over there, है ना? तो ये है, और यहाँ पे डंप करोगे and you'll be able to see the light as glowing according to input you are giving, है ना? So that will be very interesting one. If you understood the things, it will be very um, interesting for you. This is what is the verification I told you, correctness of your design that you will be doing. And last is the HDL application associate something like that. ठीक है, तो ये है आपके HDL का what we can say glance at particular point. So I'll be taking this again in the next session. So happy learning till that time. I'll be sharing the videos and go through that video. Meanwhile, just a guideline. I'll be sharing one link that is prerequisite. Hope the chat is visible to you. है? मुझे एक बार बताओ, chat आपको visible है? हाँ या ना बेटा, बोलो ना थोड़ा. 2 ही मिनट रह गए लेक्चर के.
No, ma'am.
नो.
No, ma'am.
तो जिसको विजिबल है, दो. जिसको विजिबल, अरे फिर अटेंडेंस कैसे दोगे मूडल पे? होप यू एनरोल फॉर द मूडल, है ना?
Yes, ma'am.
Better. So this is what in WhatsApp group also I'll be pasting that thing. So this is what is the prerequisite quiz. You need to, everyone has to attempt. ठीक है? Now main important part for you, that attendance, है ना? So you need to give the attendance here. Hope all of you have enrolled. I am able to see 154 participant up till now. 172. Good. So this is what is the course. Everything is shared over here. I'm going to the attendance, and within a 5 minutes you need to give attendance for this session. Wait a minute, it will not be possible if I am not able to make it. Wait a minute. So let me know you are able to give the attendance or not. Hope screen is shared and you are able to give the attendance. Yes, are you able to give the attendance? Mark your attendance. Please reply.
No, ma'am.
नहीं देता है.
No, ma'am.
No, ma'am.
No,
Are
ma'am.
you able to use this ये code T44PUV?
No, ma'am.
Attendance का option ही नहीं आ रहा
मैम
है.
द
Ma'am,
एक्टिविटी
attendance,
इज
ma'am, attendance option is only not visible.
Okay, wait a minute.
I'm this showing that activity is currently hidden.
हाँ, so I hidden make it hidden. Wait a minute. अभी कैसे बोल रहे हैं सब? हाँ, अटेंडेंस के वक्त सब बोलते हैं, है ना?
हाँ वो इम्पोर्टेंट है.
हाँ, इम्पोर्टेंट है. सीखना इम्पोर्टेंट नहीं है. ये बाकी जो फालतू चीजें है वो इम्पोर्टेंट है. फालतू भी नहीं बोल सकते आपको इसको, है ना? हाँ, अभी देखो 45 के पहले आपको करना है, अदरवाइज अटेंडेंस विल नॉट बी मार्क. एंड डोंट गिव इट टू द एब्सेंट स्टूडेंट. इतनी भी फ्रेंडशिप मत दिखाओ. वेट अ मिनट, आई विल बी गोइंग अहेड. अभी देखो हो रहा है क्या?
Yes, ma'am.
Good. So hope today's session was somewhat meaningful to you.
Yes, ma'am.
Yes. So in next session we'll be seeing continuing that particular part. Meanwhile, in WhatsApp group I'll be sharing YouTube link. Go through that YouTube link. Okay. So give your attendance. I'm here. Those who have completed that they may leave the session. Okay. Those who have given attendance, they may leave.